All right, here are perfect problem 2 solutions for Math 65. We're given a system of linear equations, except now there are 3 of them and 3 variables, x, y, and z. Kind of an added degree of difficulty. So the way you attack these is you want to kind of reduce this into a system of 2 variable equations. If you can get two variable equations, then it becomes a problem that we're more familiar with and we can solve it. And so the way you reduce this is we have 3 equations here. If you select 2 of them, you can get rid of one of the variables and then select 2 different ones and get rid of that same variable. And what you'll be left with will be kind of the starting spot for the problems we've been doing. All right, maybe I should write more, talk less. Let's say we take the top 2 equations here. So let's take this one and this one. I got 2x plus 3y minus z is equal to 5, and negative 2x minus 2y plus 3z is equal to 3. If you look at these equations and you wanted to get rid of one of the variables, x, y, or z, to me the most natural choice is to get rid of the x's. If you're going to use the addition method, which is easiest on this type of problems, we wouldn't have to multiply either of the equations by anything to get rid of the x's because we were fortunate enough to start out with exactly 2 x's here and negative 2 here. So what I would do is I would take these 2 equations and add them together right now. 2x, negative 2x, those cancel out. That was the key. We needed to get rid of one of the letters, one of the variables. 3y and negative 2y. If you add those up, you get 1y. Negative 1z and positive 3z. If you add those up, you get positive 2z. 5 and 3 is 8. So note that what I've done is I took 2 of these equations and I combined them to come up with a 2-variable equation. Y plus 2z equals 8. If I could come up with one more 2-variable equation that used the letters y and z, I would have the starting spot for one of the problems that we've been doing. So what you want to do now is choose 2 different equations, so not these same 2, but 2 different ones, and see if you can get rid of the x's using those 2. So I definitely have to use this bottom one here, right? I haven't used this one yet. So I got this x minus y plus z is equal to 2. And then I want to choose one of these top 2 equations that I will end up adding to this equation to get rid of the x's. It's your choice which one you use. You can use the first one or the second one. Since I'm going to get rid of the x's and I have positive 1x here, I think it'll be easiest to take this equation because it has a negative amount of x's already. So I'll end up with, well, I'll show you. Negative 2x minus 2y plus 3z is equal to 3. You don't want to add these equations together right now. If you add these equations together right now, you won't get rid of any of the variables. We have to get rid of our x's like we did up here. So what you can do is, if you want to get rid of the x's, you can multiply the top equation, all 4 terms here, by 2. And the reason you choose 2 is because if you multiply by 2, you'll end up with 2x here, and you already have negative 2x here, so when you add those up, they cancel out. So what I'm saying is, let's multiply the top equation by 2, and we get 2x minus 2y plus 2z is equal to 4. And then we can leave our bottom equation alone. Negative 2x minus 2y plus 3z is equal to 3. And add these equations together. Note that again my x's cancel out. 2x, negative 2x, those cancel out. Negative 2y minus 2 more y gives me negative 4y. Careful there, it'd be easy to think those canceled out too. 2z and 3z got 5z. 4 plus 3 is 7. So what I now have are 2 variable equations. I'm gonna copy them down here. I got y plus 2z is equal to 8. And I got negative 4y plus 5z is equal to 7. We've done a lot of work to get here, and we're still not done. But what I want to point out here is this is a system. There's 2 of them. A system of 2 variable equations. We only have 2 letters, y and z. This is the starting spot. This is what we've been doing, is starting out with the problem that looks like this. So for a minute, ignore all the work you've done above and just view this as a brand new problem. What would you do if you started out with this problem? Well, it depends. You'd use the substitution method if you wanted, or if you wanted to continue doing this addition method, you'd have to get rid of either the y's or the z's. I think it would be hard to get rid of the z's, But I can get rid of the y's kind of easily. I already have negative 4y here. So if I could make this positive 4y, then when I added them up, they'd go away. So that's exactly what I'm going to do. I'm going to take this top equation, and I'm going to multiply it by 4. So that I got 4y plus 8z is equal to 8 times 4 is 32. And I'm going to take this bottom equation and just leave it alone. It's confusing. Let's go, I don't know, maybe all my arrows are confusing. I'm just going to copy this, negative 4y plus 5z is equal to 7. And note that what I've done is I've made it so that when I add these equations together, my y's will cancel out. 4y plus negative 4y is nothing. It's 0. Y, it's 0. 8z and 5z is 13z. And 32 and 7 is 39. 13z equals 39. If I divide both sides of the equation by 13, I get that z is equal to 3. That's big. I don't have my answer yet, but I have the answer for one of the variables. I know that z equals 3. Maybe I'll even put a box around that. Because I'm going to use that. I'm going to take that z equals 3 and plug it into any equation that I have up above that contains the letter z and one more letter. So switch colors again. If I take, I don't know, maybe take this equation. This one looks relatively simple. If I take y plus 2z is equal to 8, and I change the z's into 3, I got y plus 2 times 3 is equal to 8. So I'm taking this z right here, and I'm plugging it in. Now I can solve for y. Y plus 2 times 3 is 6. Whoops, sorry, I wrote something wrong. This was an 8 right here, right? It's better. Y plus 2z equals 8. Y plus 2 times 3 equals 8. I accidentally wrote the wrong number there. Anyways, now we solve. 2 times 3 is 6, so I got y plus 6 equals 8. If you subtract 6 from both sides, you get y equals 2. Now I got two different answers. I know that the z's are 3 and the y's are 2. So all I need to do is figure out what x is equal to. Now I look for an equation that has x's, y's, and z's in them. Any equation that has x's, y's, and z's, totally up to you. I kind of like this one here. All the numbers are really small. X minus y plus z. See if I can copy that down. X minus y plus z is equal to, what was it, 2? X minus y plus z equals 2. And now what I can do is I can be like, yeah, this equation's true, but y is equal to 2. So instead of x minus y, I can write x minus 2 plus z, but z is equal to 3 is equal to 2. So I can plug in my two solutions. Maybe these need arrows, or maybe that's just making things worse. And I can solve for x. Negative 2 plus 3. If I combine like terms, I get plus 1. So x plus 1 equals 2. If you subtract 1 from both sides of the equation, you get x equals 1. And now I have solutions to all three of my variables. X is 1, y is 2, z is 3, which is the answer to the problem. So I'm all done with this video.